and we are into lecture number 4 in thermodynamics. What did we do in the last class? Do we remember this? We were doing processes. Do we remember the processes that we were doing? Yes or no? Remember this? Okay, let me give you a quick recap of what we had done. The first process that we had done was known as isochoric or isometric. The first process was isochoric or isometric. In this process, the volume was constant. Pressure P was directly proportional to temperature, or I can say P1 by T1 is equal to P2 by T2. The work done in this process is zero. We have already seen that. The first process, the area under PV graph. If I draw the PV graph here, volume is drawn here, pressure is drawn here. The PV graph is a straight line like this. The area under this graph, as you can see, is 0. And therefore, the work done is 0. Work done is area under graph. From first law of thermodynamics, I can write delta Q is equal to delta U plus delta W. Work done is 0. And in this process, delta U, for any process, delta U is NCV delta T, where T is the temperature. Here, delta Q is equal to NCV delta T, and delta U is also equal to NCV delta T. Do we remember this? Yes or no? Okay. The second process that we did was isobaric. In this isobaric process, what we had done was, we know that pressure is constant in this process. If pressure is constant, only volume and temperature change. V is directly proportional to T, or I can write V1 by T1 is equal to V2 by T2. Do we all recollect this? Yes or no? Okay. Then, in this process, if I draw the PV graph, this is V, this is P. Pressure is constant, so PV graph looks like this. Pressure remains P, but volume changes from V1 to V2. And this area gives you the work done. Yes or no? This work done, delta W, as you can see from the area of this graph, this is a rectangle. The area of this rectangle is length into breadth. Breadth is P, length is P2, V2 minus V1. I can write it as P into delta V. I can also write it as NR into delta T. If I talk about the first law of thermodynamics, the first law of thermodynamics is delta Q is delta U plus delta W. In this process, delta Q is NCP delta T. Delta U is always NCV delta T. Work done in this process is NR delta T. We have done this and we have seen that you can cancel this dt, you can cancel this n, and you end up with this beautiful formula. Cp is Cv plus R. This was your isobaric process. The last but not the least, the process that we did was known as, the third process that we did was known as which one? Isothermal process. In isothermal process, temperature was constant, temperature remains constant. That means pressure and volume change, and we had seen that pressure is inversely proportional to volume, or I can say P1 into V1 is P2 into V2. If I draw the PV graph for this gentleman, The PV graph is in the form of a hyperbola, rectangular hyperbola. Do we remember this? And this line is also known as an isotherm. Do we remember this? Here both the things are changing. Pressure here is P1, volume here is V1, volume here is V2, and pressure here is P2. If I find the area under this graph, the area under this graph will give me the work done. And we had seen some 1000 different formulae for finding out the work done. I am just writing one of those, 2.303 nRT log to the base of 10 V2 by V1. We had seen different variation of the same formula. Then if I write delta Q, first law of thermodynamics is delta U plus delta W. In this case, the change in internal energy is 0. So delta Q becomes equal to delta W. Do we all recollect this much? Everyone in the class recollect this much? Okay. Then if you recollect this much, we must move on to the last of the processes in this category. And the last of the processes in this category is known as which one? I hope you know the name by now. Do we know the name? Yes or no? Okay, even if you know the name, you will not be able to tell me that at this point in time. But anyways, that process is known as adiabatic process. I hope you have heard the name adiabatic process. And what happens in this adiabatic process? Well, we have seen three terms in your first law of thermodynamics. Work done. In isobaric process, work done is 0. Change in internal energy. In isothermal process, change in internal energy is 0. The third one is delta Q, or how much heat is given to the body. And in adiabatic process, what we will see in this process, delta Q is 0. That means there is no heat given to the body or no heat is extracted from the body. So it is a thermodynamic process in which pressure, volume, and temperature, all the three change. So we'll have pressure changing, we will have volume changing, and we will have temperature changing. But there is no exchange of heat between the system and the surroundings. So there should not be any exchange of heat between the system and the surrounding. For this to happen, two conditions should be met. The process must be very fast. If the process is very fast, there is no time available for heat exchange to take place. So for an adiabatic process to happen, the process must be extremely fast. Point number 2, it must take place in a perfectly insulating body. These are the two conditions that are required to make a perfect adiabatic process. Now, if you look at these two conditions, that the process must be very fast and the process must take place in a perfectly insulating body, this should remind you of something that we had done in yesterday's class. In yesterday's class also, in one of the processes, we had seen two conditions should be met so that the process can happen. Can you recollect which process was that? There were two conditions given for that process to happen. Can you recollect? That process was isothermal process. Do we remember this? What were the conditions for an isothermal process to happen? For an isothermal process, the process must be extremely slow. So I'll write here in green, the process must be extremely slow. That was the first condition. And the second condition was the process must be happening in a perfectly conducting body. Now I will highlight this with the pink ink. This pink ink wala conditions were the conditions for an isothermal process. Do we remember this? And this yellow wala condition is condition for an adiabatic process. Now from here, from these two conditions, we can assume or think of isothermal process as the reverse or the exact opposite of an adiabatic process. For an adiabatic process to happen, the process must be extremely fast. For an isothermal, the process must be extremely slow. For an adiabatic process, the process must take place in a perfectly insulating body. For an isothermal process, it must take place in a perfectly conducting body. What is the equation of state for this? We don't have any relation between P and V. PV is equal to nRT. This is not done. PV is equal to nRT is the condition. Now remember, this is the condition which is valid for an adiabatic process. This is the condition that is also valid for any other process. PV is equal to nRT is always valid for any ideal gas. But one more equation can be made for an adiabatic process, and that equation is PV raised to the power gamma. I will write it if you can't see it. PV raised to the power gamma is equal to constant. This gamma is the same gamma which is the ratio of Cp by Cv. And we have also seen the value of gamma for different gases. I'll give you a minute to note down everything that I have said. Please note down because everything that I have said is going to come in the examination hall. A minute. Have you noted it down, everyone? So fast? Well done. Well, then I will move on and I will give you the other two ways of writing the same thing. Which thing I am talking about? I am talking about an adiabatic process. So I hope you have noted down till here. And now you will note down what I am writing on the board. So what I have given about adiabatic process, the first thing is there is no heat involved in this process. Delta Q is 0. The second thing is P, V, and T. All things change. All the three quantities change. Number 3, the equation of motion. I am saying the equation of state is PV is equal to nRT. This is valid for all the cases. The fourth thing that I have told you is one equation can be written as PV raised to the power gamma is constant. Now, this is one way in which you can write it in terms of P and V. So, if one pressure is P1, other pressure is P2, why I'm writing V2? One pressure is P1, the other pressure is P2, then P1 V1 raised to the power gamma will be equal to P2 V2 raised to the power gamma. Do we understand this? Where gamma is the ratio of specific heat Cp by Cv. Now this is one way in which you can write this, the yellow way, in which you can write this in the form of P and V, relation between P and V. But there are other ways in which you can write this. For example, you can write it in terms of T and V. T is the temperature, V is the volume, and how do you write it? TV raised to the power gamma minus 1 is constant. Or you can say it in this way, T1 V1 raised to the power gamma minus 1 will be equal to T2 V2 raised to the power gamma minus 1. This is the green way of writing the same thing. The green way is nothing but written in terms of T and V. Here what I have done, I have converted P into T. I have converted pressure, PV is equal to nRT. I have converted P into T, and that is how the equation looks like. Do we understand this? Can I have some raise hand that we understand this? The third way of writing the same equation is in the form of T and P, and this is how it is written: T raised to the power gamma, P raised to the power 1 minus gamma is constant. This is the most difficult one to remember. The easiest one to remember, which I've always trusted, is the first one, the yellow one. The other two may not be so easy to remember, but if you can remember them, well, you would have done a very, very good task. So this is the pink way of remembering it. Remember, all these three ways are not different. They are derived from each other. What I have done in equation number 3 is I have converted V into P, or you can say I have converted V into T from this equation. Are we understanding what I am saying here? If you can remember one, you can remember the other two, you can formulate other two, you can derive the other two, but in the examination hall, you will not get enough time to derive them. So it is your duty bound to remember them so that you don't have to derive them in the examination hall. I'll give you a minute to note it down. Have we done this? Okay. Then we will move ahead in life, and the next thing is, as always, the work done in an adiabatic process. Gas is taken from one stage P1 V1 T1 to other state P2 V2 T2, and I know that P1 V1 raised to the power gamma is equal to P2 V2 raised to the power gamma, and I have also seen the other two ways of writing the same thing. So you will write from here to here. You understand this? Everything else is just a derivation. We will not write the derivation of this entire thing. what you got to understand is this is the first way in which I can write the work done for an adiabatic process. 1 upon gamma minus 1 P1 V1 minus P2 V2. This is the other way of writing the same thing in terms of mu R and T. Mu R and T. Mu means number of moles. I'll write it as N R and T. N R upon gamma minus 1 into T1 minus T2. So you must remember both of these ways to find out the work done by adiabatic process. I'll give you a minute to note this down. Are we done with this? Can I have some raised hand that we understand this? Okay. 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 Let's move ahead in life. And this is how I move ahead in life. Now, many a times what I have seen is we get confused in the formula for work done for an adiabatic process. We get confused in the formula for work done by an adiabatic process. I repeat, we get confused in writing the formula for work done by an adiabatic process. So there is a simpler way to remember it. And please pay attention on that simple way. And how do I get that simple way? That simple way of remembering the formula comes from first law of thermodynamics. Delta Q is equal to delta U plus delta W. Do we remember this first law of thermodynamics? I only see one hand. See, I have two hands. Okay. Now, the simplicity comes from this thing that we understand that in an adiabatic process, delta Q is 0. Yes or no? That means I will have this formula, delta U is negative of delta W. Yes or no? Delta U is negative of delta W. And I know for any process, delta U is always equal to NCV delta T. Do we understand this? Now this, in this process, is negative of work done. So I can write work done as negative of NCV delta T. Do we understand this? Do we understand this? Now see how that formula comes, which you might find difficult to understand. The value of CV, and we have seen it in the previous classes, the value of CV is R upon gamma minus 1. So I put the value minus N R upon gamma minus 1. Delta T is T2 minus T1. We have a negative sign here. This negative sign goes inside, and I have the formula that we get NR upon gamma minus 1 into T1 minus T2. Instead of writing it as NR into T1 minus T2, you can write it as P1 V1 minus P2 V2. So I have told you the easier way to remember this. If you can remember this, well done. If you can remember it in the original form, well done. If you just remember that delta U is negative of delta W, you would be able to solve any question. Do we understand this? Then you will write everything that is given in this sheet, because everything will come as a question in your exam. Delta U is negative of delta W. That means whatever work is done in an adiabatic compression or expansion, that work done gets converted into change in internal energy. Then some very important points. Point number 1, if the gas expands, work done is positive. Work done is positive. If work done is positive, delta U is negative. That means the gas will cool down. If the gas expands adiabatically, the gas will cool down. Do we understand this? You can do the same thing in the reverse way, which is point number 2. If the gas is compressed, work done is negative. In that case, the gas will heat up. You can understand it by common sense. For an adiabatic process, if you compress something, if you compress a gas, temperature has to increase. You will have to write each and everything that I have given you. Please note it down. I'll wait a minute for you to do it. I hope you have noted this down. Then what is next? What is next is this PV graph. The PV graph for an adiabatic process. Now the adiabatic process is PV raised to the power gamma. We don't have to understand this. We don't have to understand this. We just need to understand what is the slope of PV graph for an adiabatic process, and it is equal to minus gamma times P by V. Minus gamma times P by V. If I talk about an isothermal process, the slope of an isothermal process is minus P by V. Do we remember this? That means the slope of adiabatic curve is gamma times the slope of isothermal curve. Do we understand this? Slope is more, that means the curve would be steeper. We will see that in the next graph. Right now what I want you to write is this one, and this tick mark. Also write the slope of an isothermal is minus P by V. And remember that slope of an adiabatic process is gamma times the slope of isothermal process. Adiabatic process is steeper than isothermal process. Have you written this? Now, if you have written this, then what you are going to do is we are going to see this graph, and remember this graph is the most difficult question that can come from this part. And if you understand this question, this is the most difficult question that can come from this part, and this is the graph wala question. Now remember this graph has been drawn ulta, so I will just सीधा करो it. Now here are three graphs, as you can see, drawn for adiabatic process of three types of gases. The first gas is monoatomic, the second gas is diatomic, and the third gas is polyatomic. Do we understand this? Okay. Now remember, it has been marked wrongly. For a monoatomic gas, the value of gamma is 1.67. Do we remember this? And therefore, this graph, the graph for monoatomic gas, the graph which is the lowest in the three, is the steepest graph. It is very steep. And this is the graph for a monoatomic gas because the value of gamma is the highest. The value of gamma is the highest, 1.67, and therefore the graph for monoatomic gas is the steepest. Do we understand this? Then we look at diatomic gas. The value of gamma is 1.4. It is steep, but it is less steep compared to monoatomic gas. If you look at the last graph, which is the upar wala graph, this is the graph of a polyatomic gas. The value of polyatomic gas ka gamma is 1.33. This is the lowest gamma. This is the lowest gamma, and therefore the graph is very less steep, and it is the upar wala graph. Do we understand this? Can I have your raise hand that we understand this? The सबसे ऊपर वाला graph, the topmost graph is for polyatomic gas, बीच वाला graph is diatomic gas, and the lowest graph is for monoatomic gas. Do we understand this? Now remember, this was the graph for adiabatic expansion of the gas. Please note it down. This was the graph for adiabatic expansion of the gas, and correct what was wrong. If you are drawing it in the notebook, that is good. If you are doing it on the sheet, well, I don't appreciate that very much. But since we don't have much time, you can do it. Now, I will show you the next graph, which would be the graph for adiabatic compression of the gas. So volume will be decreasing, and I would be asking you which graph is which. I hope you can see this. So I'm now going to draw three different graphs for adiabatic compression. This is V, this is P. Since it is compression, the volume is going to decrease. The volume is going to decrease. So I draw three graphs. This is the blue graph. One is the green graph. All these are compressions because volume is decreasing. And the third one is whatever color this is, that graph. So I've drawn three graphs. These are the graphs for adiabatic compression. Now you have to tell me which graph is for what gas. This is graph number 1. This is graph number 2. And this one is graph number 3. Which graph belongs to which type of gas? Monoatomic, diatomic, or polyatomic? The simplest one is the diatomic gas. Which is the graph for diatomic gas? 1, 2, or 3? Which one is the graph for diatomic gas? And the answer is 2. Yes, the beach wala graph is always for a diatomic gas. Do we understand this? Because its slope lies between first graph and the third graph. Now, the only point of contention is if you understand any one of these graphs, the third one is simple. So now I ask you, which one is the graph for monoatomic gas? Which one is the graph for monoatomic gas? Remember, it has to be the steepest graph. The steepest graph is for monoatomic gas, and the answer is graph number 1 is the steepest graph, and that has to be the graph for a monoatomic gas. For a polyatomic gas, the graph has to be very less steep, and that is graph number 3. So this is how the graph will look like for compression. The graphs are similar. Don't get confused which is top, which is bottom, which is in between. Do not look at top, bottom, in between. Always look for which one is steeper. Do we understand this? Steepest graph is monatomic gas. Don't look top, bottom, and in between. Don't look at that way. Always look for the steepest graph. Steepest graph is for monoatomic gas. That was the entire contention. I'll give you a minute. Till then, I'll switch on my slides. And you have time to note it down. Noted it down. Then we come to this one, and we have already discussed this. Oops. That the slope of an adiabatic curve is always greater than the isothermal curve. dP by dV, which is the slope for an adiabatic process, is gamma times the slope of isothermal, or slope of adiabatic divided by slope of isothermal is gamma. Since gamma is always greater than 1, so adiabatic is always steeper than the isotherm. Do we understand this? You will write whatever I have taken now, then we will discuss which graph is for which one. I'll give you a minute. Have you noted it down? Then we come to this one. There are two graphs given. One is for isothermal process, one is for adiabatic process. Do we understand which graph is for what? Do we understand which graph is for what and why? Isothermal process is less steep. Adiabatic process is more steep. Do we understand this? Yes or no? Isothermal process is less steep. Adiabatic process is more steep. We understand this? This is the graph for expansion, the red one. Now in the same, I will draw the blue graphs, which are for compression. You don't draw it in this diagram. You will draw it in a different diagram. For compression, I will draw these two graphs, the blue graphs. This graph will be graph number 1 and this graph will be graph number 2. I'm just drawing it on the same P and V axis. You have to draw it differently. Now tell me, for an isothermal process, which graph would be there? Graph number 1 or graph number 2? Graph number 2 in the blue line, in the blue graph will be the graph for isotherm. Graph number 1 would be the graph for adiabatic. Do we understand this? Please draw this graph separately. The blue one are the graph for compression, adiabatic compression of the gas. Have you noted this down? Okay. Now here are some examples of an isothermal process. Here you can see bursting of a cycle tube, spontaneous, happens very fast. Propagation of sound waves in a gas. Remember this, very important point. Propagation of sound waves in a gas, adiabatic process. In diesel engine, the burning of diesel without spark plug is because of adiabatic compression. If I have gas in a thermally insulated vessel, look at this thermal flask. If I have gas inside this flask, it is insulating. Whatever happens to gas inside this flask is adiabatic process. If the gas is suddenly cooled or suddenly expands very fast, two things must be there. It must be a very fast process. It must take place in a perfectly insulating environment. Those two processes, those two conditions make the process adiabatic. Do we understand this? Yes or no? Can I have some raise hand that we understand this? Well, any of these points can come, will come. I'm sure it will come as questions in your exam. Please remember them, bacha. I would be very disappointed if you don't remember them and you become Ghaznis. There is no place for any Ghaznis in the examination hall. Right? We have seen all the four processes, and now what I'm going to show you is the graph of all those processes in the same frame. Do we see this? And we now see the slope of all the four graphs put together. IM means IM means isometric process. The slope is infinite. Do we understand this? AD means adiabatic. AD means adiabatic. This is AD. This is isometric IM. The most of the biggest slope, which is infinite almost, is for isometric or isochoric process. Then you have adiabatic process. Then you have IT. IT means isothermal process. I hope you are drawing all these things together. 4 graphs in the same page. And the last one is IB, means isobaric process. This is IB, IM, AD, IT, IB. The slope is 0. I hope you have drawn this and remember the sequence of slopes. Please write it. Draw the graphs. We are done. Everything here is from your sheet, so you can see it in your sheet and understand this. If you have done, please raise your hand so that I can move forward. Okay. That takes me to this simple thing that are given in your sheet. I'll just go through this graphical problem. Which of the graph number 1, graph number 2, which of the graph is isothermal and which of the graphs is adiabatic? I'll ask you, which one is adiabatic, number 1 or number 2? Number 1 is adiabatic. Do we understand this? Okay, sir. Then, sir, the same question put in a different way, sir. The graphs are overlapping, so I have to show you a bigger picture. I'll have to show you a bigger picture. So I'm showing the bigger picture of question number 2 here. I hope you are seeing this question on your sheet, and this is the question from your sheet. Now look at equal expansion. Initial volume is V, final volume is 2V. Do we understand this? The first graph is isobaric. The second graph is isothermal and the third graph is adiabatic. Do we understand this? Look at the order of work. Work done in isobaric is the highest. Area is सबसे ज़्यादा. Then the work done in isothermal. Then the work done in adiabatic. Do we understand this? Similarly, pressure is highest in the final pressure I am talking about. The final pressure is highest in isobaric process. It does not change. Then the second one is the pressure in isotherm, and the third one, the lowest pressure, is in adiabatic process, the final pressure. Are we getting this? Anyone got this? Okay. Now look at this green graphs. These green graphs are for the blue graphs were for expansion. The green graphs are for compression. I am compressing the gas in 3 different processes. The first one is isobaric. The second one is isothermal. And the third one is adiabatic. And you can see work done in adiabatic process here. That is the process that is on the top, which is the steepest. Work done in adiabatic is more than work done in isothermal, is more than the work done in isobaric process. The order of final pressure has also reversed. The pressure in the adiabatic process is the largest, is the highest, followed by pressure in the isothermal process, followed by the pressure in the isobaric process. Have you noted this down? Please note this down. I'll give you a minute. I hope you have done this. Then comes the next thing, and these are the questions that I have come. That comes every time. They give you a cyclic process. The process starts from A, then it goes to B, then it goes to C. Pressure and volume are given, and they ask you how much is the work done for this cyclic process. And I told you the work done in the cyclic process is the area in between the graph. Do we understand this? You basically have to find out the area of this triangle, which is half base into height. So half base is this one, base is 2v1, and the height is this one, which is 3p1. Do we understand this? From there, you can find out the work done in this process. Now, work done in this cyclic process can be positive, can be negative. Look at this cycle. This cycle is happening in the anti-clockwise sense. Do you understand anti-clockwise sense? The cycle is happening like this. This is anti-clockwise, and therefore anti-clockwise work done is taken as negative, and that is why the answer is minus 3 times P1 V1. Do we understand this? We will be doing questions here. This is just for your practice that we are doing this. I'll give you a minute to note this down. Have you noted it down, bacha? Well done. Then comes, we'll be solving these 4 or 5 questions, and I'm sure in these 4 or 5 questions, we will be doing the entire spectrum of questions that can come for you in the examination hall. So this is question number 5. For an ideal gas, this is from your sheet. You can see it in the sheet. For an ideal gas, heat gained to the system at constant pressure. Remember, the process is constant pressure. So 200 joules of heat is given. Constant pressure is 20 Newton per meter square. The volume reduces from 8 meter cube to 2 meter cube. What is the change in internal energy of the gas? I'll give you a minute to solve it. I hope you would be able to do this. Please carry on. What is given? The heat given to the system is given, delta Q is given, pressure is given, how much the volume has changed is also given. You have to find the change in internal energy of the gas. I'll give you a minute. Anyone able to do this question? Well done. I'm very happy if you have done this. How are we supposed to do this? It is pretty simple. Since you don't have the mic and the pleasure that you can talk, I will do it on your behalf. So how you are supposed to do this? Just apply the first law of thermodynamics. Delta Q is delta U plus delta W. Do you understand this? Heat given is plus 200. Work done is not known. Change in internal energy. You have to find out how will you get work done. It is a constant pressure process. P is constant multiplied by change in volume. Final volume is 2. Initial volume is 8. 2 minus 8. So it automatically becomes minus 120. Do we understand this? From here, it's simple addition. Add, subtract, and you get the change in internal energy is 320. This is positive. That means the temperature has increased. Do we understand this? Yes. Then we move on to the next topic, next question. Simple questions with simple answers. But they cover almost all the type of questions that have ever come in the exam. Trust me on this. And that is why we are doing them separately. Are we ready for the next one? And the next one is not a surprise. It is the next one in your sheet. This is question number 6. Find out the relation between V1 and V2. Basically, when they say find out the relation, they mean which one is more, either V1 or V2. And I am waiting for your answers. Which one is more, V1 or V2? And how do you find it out? It's as simple as that. How do you find it out? I'll give you a minute to think about it, to think about questions which can come in this category. I'll give you a minute. If you can tell me the answer and why is the answer this, I would be pretty happy. You got the answer, anyone? Okay. And what is the answer? Let us have a look at the diagram once again. I hope you can see the diagram on full screen. Yes or no? Now, this is a diagram between P and T. Now, what I have done, I keep the pressure constant. So what I do is I draw a red line which is parallel to T or x-axis. Now at this red line, the pressure is constant. Do we understand this? At this red line, the pressure is constant. And we must remember that. We must remember what? We must remember that PV is equal to nRT. Now what I have done is I have kept pressure constant. Number of moles is always constant and R is always constant. So now I have volume is directly proportional to temperature. If the temperature is more, the volume is more. Now look at here very closely. Look at T2, look at T1. Which temperature is more? Definitely, my dear friends, T2 is more, and therefore your volume V2 is greater than V1. T2 is more than T1, and therefore V2 is more than V1. Do we understand this? Everyone, do we understand this? Okay. That is the entire concept, and that is what is explained in the solution, which is also given in your sheet. I'll give you a minute to note this down. Any question that comes in this category, you should be able to do this. No matter the question is in a straight line. Even if it is not a straight line, you can still do it. For example, if the question was like this, ding, ding, this is T, this is P. I'm drawing it in terms of T and P. Remember that. And now I draw two graphs. Now these are not graphs at constant pressure or constant volume. What I have done is I have given you the volume here is V1 and the volume here is V2. Now can you tell me at these 2 points which volume is more? V1 is more or V2 is more? Which is more, V1 or V2? V2 will be more because at constant pressure, this is at a higher temperature and this is at a lower temperature. Do we understand this? This is how you solve question of this category. And I have one more coming up for you. No prizes for guessing this one. This is question number 7 for you guys. And I hope you would be able to give me a correct answer. Here it comes on your screen. Find out the relation between P1 and P2. The question has been just changed from V1 and V2. The question has been made from P1 and P2. May I have your answers, please? Which one is more? Do I have the answer? And the answer is simply, instead of drawing constant pressure line, here I will draw constant volume line. Do we understand this? Instead of drawing a constant pressure line, I will simply draw a constant volume line. This, my dear friends, is a constant volume line. Now, if the volume is constant, pressure is directly proportional to temperature. As you can all see, T2 is more than T1, and therefore this pressure P2 will be more than P1. Do we understand this? Can I have a raise of hands from everyone? I hope you are understanding what is going in the class and everyone is attentive in the class. Sometimes what I see is students in the class of physics, they are doing biology. In the class of biology, they are doing chemistry. In the class of chemistry, they are doing physics. Now, if you mix things like this, your brain is not a mixture. Your brain can only do one thing at one time. So in the class of physics, you must study physics. In the class of chemistry, you must study chemistry. And in the class of biology, you must study biology. Otherwise, you will not be good in physics. You will be bad in maths, you will be bad in chemistry, and you will be bad in biology. Do we understand this? The significance of this? Your brain can only do one thing at one time. Your brain cannot multitask. Do we understand this? A brain is a simple device. It's a very complicated device, but it does simple things and it can only do one thing at a time. So please remember that. And now the question comes. This question we have already done. It's a PV graph. And what are these three things known as? Graph number 1, graph number 2, and graph number 3. Do we remember these are known as isotherms? Yes or no? These are known as isotherms. They are drawn at different temperatures. Can you tell me the relation between T1, T2, and T3? Which is the highest temperature, which is the lowest temperature? You always know which is the beach wala temperature. Which is the highest temperature and which is the lowest temperature? Which is the highest temperature? We have already discussed this. T3 is the highest. Do we understand this? Yes or no? T3 is the highest temperature. The logic is still same. They draw line and they draw a line at constant pressure, and then you can find out wherever the volume is more, the temperature is more. This is the concept. Do we understand the concept? Yes or no? Yes, sir. No, sir. Better I go, sir. Better I do this thing, sir. And now finally we come to the last thing, which I think I had told you to do before coming to the class today. Do you remember what I told you to do before coming to class today? No, we don't remember it. Good. So I must refresh your memories because I know that you have got this Gajini problem, short-term memory loss. I told you to draw this table and understand this table. Everything that we have discussed in this chapter is given in this one table. 4 processes we have discussed. If I can make you remember, isochoric or isometric, isobaric or IB, isothermal or IT, adiabatic or isentropic. Remember this name, isentropic. Remember this name, isentropic. Remember this name, isentropic. Do we understand this? Now I'll quickly go through what are the constant parameters, what remain constant in isochoric volume, in isobaric pressure, in isothermal temperature, and in adiabatic. There is no heat transfer. The other, the other word is there is no change in entropy. Do we understand this? Gas law, which gas law is applicable? Ideal gas law is always applicable, but here it is Gauss's law, constant volume, Charles law, constant pressure, Boyle's law, constant temperature, Poisson's ratio, PV raised to the power gamma is constant, that is Poisson's ratio law. Do we understand this? Equation of state, P is directly proportional to T, V is directly proportional to D, PV is constant. Here there are three different or 4 different formulas are given. PV raised to the power gamma is constant, TV raised to the power gamma minus 1 is constant, P raised to the power 1 minus gamma, T raised to the power gamma constant. Or the last one, the smallest one, is P into rho. Rho is density. Density to the power minus gamma is constant. Do we see this? Next one is work done. Work done is 0. Work done is P into delta V or NR into delta T. Work done is falana falana. We have seen the different variation of the same problem. Work done here is negative of. This is negative of change in internal energy. Do we remember this? First law of thermodynamics, delta Q is delta U, which is NCV delta T. Here, delta Q is NCP delta T. Delta U is NCV delta T. Here, delta U is 0. Delta Q is equal to delta W. Here, delta Q is 0. So, the work done is minus of du. Do we remember this? PV graph, 90 slope, 0 slope. Slope is minus P by V. Please remember this. Slope is minus gamma P by V. Do we remember this? I'll just give you a moment of silence to let's move ahead in life. Slope of PV graph for a constant volume pressure is infinite. Constant pressure process slope is 0. For isothermal, minus P by V. For adiabatic, minus gamma times P by V. This is the slope. The heading is wrong. This is the slope wala heading. Now, the specific condition wala heading is here. The condition for this to happen, it should happen in a closed container. Whatever happens in a closed container, it has constant volume. Whatever happens in an open container, which is open to atmosphere, it is constant pressure. Do we understand this? Whatever happens in a conductive vessel and very slowly, it has to be isothermal. Whatever happens very fast or in a insulating vessel, that is an adiabatic process. Do we understand this? Example of these processes: for a constant volume process, heating of solid and liquid. For a constant pressure process, phase conversion. For constant temperature process, all phase conversion. And whatever happens in the environment, because atmospheric pressure is constant. For adiabatic process, I have already told you all these things. If you can remember them, it is very, 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 very good. Have you noted things down? Now, shall I move to the part which I love the most? And the part which I love the most is this. And we start from the next possible question that I see on my screen, and the next possible question that I see on my screen, but you don't see on your screen because it is getting disappeared, is here. An ideal gas is taken around the cycle ABCA, ABCA. In this cycle, the amount of work done is how much? How much is the work done? A, B, C, D. There are 4 options. Obviously, this work done is positive because, oops, what I have done here, I've done something wrong. Whatever, this is a cyclic process, so work done is positive. Do we all understand this? I mean, this is a clockwise process, the work done is positive. Now you have to tell me how much this work has done, and your time starts now. A, B, C, D are the 4 options. Which one is this? And as you remember, we have already done this question, but it was clockwise ki jagah anti-clockwise process, and we found out that the work done is area of this triangle, half base into height, half is half, base is 2v and height is 3p. Yes or no? Answer becomes 3 times PV. That is correct. If you have done this, you have done exceedingly well. And that would take me to the next possible question. And the next possible question is this one, my dear friends. I hope you can tell me the answer for this one. Arrange the following in increasing order of work in equal expansion process. As I told you, whatever is required, I have already told you. Now it will come as different sort of questions. Question number 96 is on board. Tell me the answer. Remember, it's expansion, not compression. A, B, C, D, 1, 2, 3, 4. Do we have the answers, my dear friend? Well, if you don't remember the answer is D, none of the above. Most of the work is done in isobaric, then isothermal, then adiabatic. In expansion, in compression, it is ulta. Adiabatic is more, then isothermal, then isobaric. You don't remember it, so you get -5 for this. Well, you only get -5 when you attempt it. If you don't attempt the question, you get 0. Anyways, in my scoreboard, you get -5, but you have time to redeem yourself. As I always tell you, you are like cash vouchers, can be redeemed at any point in time. And this is the question of redemption. A system does 50 joules of work under adiabatic condition. In this process, what will happen? A, B, C, D. Do we have the redemption question? Do we have the redemption? Do we have redemption? Shawshank Redemption, the highest rated movie on IMDb. Do we have redemption here? 97. No redemptions here. Taking too much time to read the question and answer it. Anyways, you're doing for the first time, maybe that's why. Temperature of the system will increase, temperature will remain constant, internal energy will increase and internal energy will decrease, and the answer is 4. So you all of you get -5. If you remember, and you seem to have a problem of Mr. Gajani, and this problem is very dangerous in your profession because you might lose or you might forget a scissor in the stomach of your patient, and then you will face dire consequences. Don't become Gajani. I told you delta U is minus delta W. When the gas expands in isothermal process, it cools down. How many times I have to tell you the same thing? Well, -5 again. So your net score is -10 out of +8. Ooh, so you have lost 18 marks. See, it's just not -10. It was +8 also. So if you do 2 questions wrongly, how many marks you have lost? You have lost 18 marks, my dear friends. 18 marks. Too much of loss. Let's see. Again, you have cash vouchers. So again, I'll try to redeem you. If you are not getting redeemed on Zomato, I'll try Swiggy. If not Swiggy, I'll try Ajio. If not there, I'll try it Flipkart. Somewhere you will get redeemed. This one. In an isothermal process, applied heat to an ideal gas is used in dung, 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 dung. +5 or no, -5 or +4. Your score is -10 right now. It could have been +8. So you are losing 18 marks. You are losing 18 seats. 18 seats in Lok Sabha will make or break a party. You're losing your majority. Yes. In an isothermal process, the supplied heat to an ideal gas is used in. And the answer is? I don't see your hands, so I cannot tell you. 1, 2, 3, 4. It's an isothermal process, so temperature cannot change. So this goes away, this goes away, this goes away. The only possible option is B. And that is the correct answer. If you got it correctly, then from -10, you have moved to -6. If you have got wrongly, then you are at -15. You could have been at +20, +12. You'll say, sir, why are you cutting -5? You should cut -1. No, in my maths, I cut -5. I don't cut -1. Just to tell you how much you lose if you lose on these questions. Can I move on the next one? Chalo, let's see this one. Again, this is summer sale. And the gift vouchers are valid here also. So you can redeem yourself. Graph between PV graph for isothermal and adiabatic process are drawn. What is the relation? AB, CD. Which one? This one. I hope you will get it correctly. And the slope of adiabatic curve is gamma times the slope of isothermal curve. That is the correct answer. I hope you have redeemed your vouchers. Next one is this one. 101. It's quick. In an isothermal state process, basically, which of the following statement is true? Congratulations, you have scored -5. Because first is correct, second is also correct. Therefore, the correct answer is D, not 1. Internal energy and temperature are related to each other. If the temperature is constant, internal energy will remain constant. So again, anyways, remember these questions are going to come in the examination hall. Then don't do this mistake. Again, redemption. The following is wrong in an adiabatic process. What is wrong? It's not about right. It's sometimes about wrong. Which one? And the answer is 4. Entropy does not remain constant because entropy remains constant. That is correct. Let's see who can do this. A system is taken from initial state P1V1 to a state P2V2. The heat given to the system is delta Q and the work done by the system is delta W. Then the quantity that will remain constant in this process is what? First of all, you have to understand which process are they talking about. If you understand the process, then the rest of the part is pretty damn simple. Kajal has not given a single answer. I think she is making notes. Rajal, are you there in the class? Making notes? Lots of notes? Okay. Chalo. What about this one? Which process are they talking about? They have not mentioned temperature here. So the process that they are talking about will happen at constant temperature. Therefore, it's an isothermal process. If it is an isothermal process, delta Q does not remain constant. Delta W does not remain constant. Delta Q plus delta W is nothing. So the answer is delta Q minus delta W, because that is equal to the internal energy ka change, and internal energy does not change. Do we understand this? Yes or no? Okay. Let's move our attention to the next question, and the next question arrives with a bang. Let's see if we can bang it. Let's see this one. Delta Q plus delta U plus delta W is 0 is valid for what? This equation is valid for what? A, B, C, D. Redemption. And the answer is here delta U plus delta W is delta Q. Delta Q is 0. That means the process has to be adiabatic. Yes or no? Yes or no? Okay. Keep your spirits high, bacha. Let me come to a slightly tougher one, and this is the slightly tougher one. A system is taken along the paths A and B as shown. The amount of heat given in these processes are QA and QB. What is the relation between QA? This is process number A, upar wala. This is process number B, niche wala. This is question number 106. 106. This one is the initial stage. This one is the final stage. Can I have your answers? And the answer is 4. Why the answer is 4? In both the process, delta U is same because it is going from one stage to the second stage. Delta U does not depend on the path. So delta U is same. If delta U is same, delta Q, which is equal to delta U plus delta W. Now for both this process, change in energy is 0. So heat given will be more where work done is more. Now in which process the work done is more? The process in which the area is more. In which process the area is more? The upper wala process, the area is the area in blue. For the niche wala process, the area is area in green. We understand that area in green is less than the area in blue, and therefore the answer is 4. Do we understand this? I think we have done a question similar to this yesterday. I just wanted to check whether you understand it, remember it. Now comes this one. As you can see, what we have done a lot of things. And the questions which are coming are pretty straightforward. 116 is the question, and Kajal is going to give me the answer for this one. Kajal, what is the answer for this? Isometric change. The first question is for Kajal, what is an isometric change? Isometric change, Kajal, happens to be isocoric, constant volume. And what is the answer? It's a constant volume process. So what is the answer? I think you have got some divine help from someone Someone has helped you out? Yes or no? See, I might not be able to hear you, but I'm like God. I'm omnipotent and omnipresent. I'm present in the class. You might not see me. I'm there. And the answer is 1. So I must congratulate the God who has helped you. Delta Q is delta U plus delta W. It's an isometric or isochoric change. Same volume. Work done is 0. That is why the answer is A. Do we understand this? Remember, I am omnipotent and omnipresent. I am present there. Do not take me for a ride. Whatever you are doing, I have done it in my time, and I have seen thousands of students do this. This is the next one, 117. In the following process, the internal energy of the gas will increase. Oh. Think about it and let me know. In which process the internal energy of the gas increases? I'll give you a minute. And what is the answer? And the answer is 2. If you said 2, that is correct. Adiabatic compression, there is no heat lost or heat gain. If you compress the gas, temperature increases. If you expand the gas, temperature decreases. If temperature increases, internal energy increases. Internal energy is related to temperature. I hope I have said this enough times that it should have gone directly into your head. Yes or no? Has it gone directly into your head? I always say that God has given us 2 years. 1, 2. What are the reasons for 2 years? He could have given us 1. I find the reason behind it. He has given us 2 years so that if you hear something which is not good, bad, not of your use, useless, so you take it from 1 year and you let it go from the second year. So one is inlet, the other one is outlet. That is where you use both the ears. Now, when you hear something which is useful, important to your life, so you hear it from both the ears, 2 inlets, and then you let it go inside your brain and inside your heart and your body. That is the reason you have got 2 ears. So when you hear something useful, 2 inlets. When you hear something which is crap, 1 inlet, 1 outlet. Why did I tell you this? Maybe some reason. Anyway, so I've told you enough times that you must remember it. You must have used both your inlets and not 1 inlet and 1 outlet. Same question put in a different way. A quantity of air whose gamma is 1.4 at 27 degrees Celsius is compressed suddenly. What will happen to the temperature of the gas? Rise, fall, remain unchanged. First rise, then fall. Wow. This is Aligarh Muslim University, AMU. Do we have any answer for this one, bacha? Rise, fall, rise. You only rise when you fall. That's an old saying. And here, I forgot the name, yeah. See, I'm very bad with names. I forgotten the name. Okay, she has woken up and see, I've got short-term memory loss. This is what I call short-term memory loss. I have it, and I don't want you to have it. So this is adiabatic compression, and the temperature will rise. Do we understand this? Okay. See, I forgotten your name, bacha. So you are the name just skipped my conscious. So 1 inlet and 1 outlet. Something has happened. Okay. This one. At constant pressure, work done in changing the volume from V1 to V2 is different options. And the answer is 4. Yes, P into V2 minus V1. So finally, everyone has woken up. And this is good. Well done. 133. I'll do as many questions as they are possible, because I know that from one of these, the questions will come, and then probably you'll remember me. Remember, I am omnipotent and omnipresent, but I will not be present when you are giving your exams. That is the problem with me. That is the problem with God, and that is the problem with your luck. Your luck will evade you when you most need it. Your God will evade you. You will feel that your God has evaded you, has left you in the examination hall without any help. But that is not the case. The God is always there with you. You only feel that He has left because you are in distress and your mind doesn't work. If an ideal gas is compressed during isothermal process, what happens? Dung, 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 dung. It's an isothermal process. Gas is compressed. What happens to this? 133. And the answer is? And the answer is 2. God is helping you a lot. So how do I get the answer? For an isothermal process, delta Q is equal to delta W. The gas is compressed, so this is negative. If this is negative, this will be negative. This is negative means the gas is rejected by the system. Do we understand this? Yes or no? Okay, then that takes us to the last set of questions. I don't know how many I would be able to cover, but I'll try my level best. And this is one. A bottle is filled with water at 30 degrees Celsius. And I take it to the moon. So, you see how many efforts we have to make a question for you. You have to go to moon to make a question. What will happen? Water will freeze, water will boil, water will decompose into H2NO2. Nothing will happen to water. Water remains water. What happens? Interesting question. You're not. You'll say that why this question? We are never going to moon. You might not, but your coming generation may be colonizing Mars. Mars. Elon Musk is already sending probes, and we are trying to colonize Mars. We might even colonize Moon as well. I've already booked a space on Moon. There was a point in time where spaces on Moon were being sold out. I was having enough money. I bought a very large piece of land on Moon. You could not do it now because the scheme is already over. I have also bought some stars. There was a point in time when stars were being sold. When they were not being sold, you can name a star and they will name a star for you. So I named some 4 or 5 stars. So I have some stars in my name and I have a piece of land in Moon. Why did I tell you that? Because for this question, because if I land up on Moon, I will be using that space. And it's a very vast space. I can build an entire city over there, small city. Yes, water will freeze, water will boil, water will decompose, nothing will happen to water. So we know that 2 things are not going to happen. C and D are completely out of the question. This is not a question of physics. So this is not a question of chemistry. So water is not going to break into H2NO2. Nothing will happen to water. That will also not happen. So whether it will freeze or it will boil. Now remember, water is in a bottle. Bottle is having a constant volume. Do we understand this? Then what? Remember, when you decrease the pressure, the boiling point comes down. Do we understand this? So if you want to boil, normally at atmospheric pressure, water boils at 100 degrees Celsius. But if I want to boil water at a lower temperature, what do? I decrease the pressure. If I decrease the pressure, the boiling point of the water comes down. So the only option that is possible is water will boil. It will start boiling. Water will boil at 30 degrees Celsius when the pressure becomes almost zero. In fact, I have boiled water at around 37, 38 degrees Celsius. When I was working as a marine engineer, we have these freshwater generators. What do? We take water from the sea, which is salty water, and we generate fresh water from that. In that freshwater generator, we boil the water at very low pressures, and we boil it at around 37 to 38 degrees Celsius. So this is what I have seen in real life. This is no science fiction. I don't have to go on moon. Just go on a ship, look at a freshwater generator, and you have your answers. Do we understand this? Yes or no? Again, you can see same questions have been asked in different ways, and this comes here. It comes question number 127. When a gas is adiabatically compressed, then its temperature increases because temperature increases, and the only option that matches the temperature increasing is internal energy is increasing. Do we understand this? In adiabatic process, work done is not zero. Heat is not supplied. Here it is given heat is supplied. Pressure will always change. Pressure, volume, and temperature always changes. The only option is internal energy changes. So there are many ways in which you could have done this question. Do we understand this? Now comes this one. So this is question is wrong. I'll have to move on. This one. Question number 157. I hope you can see it. During isothermal, isobaric, and adiabatic process, work done for the same change in volume. Here they are showing expansion process, and the correct answer is isothermal, isobaric, adiabatic. None of the above. And the answer is simply, in which process the work done is maximum? Which process work done is maximum? You can see the maximum work will be done in process A, and process A is isobaric. Do we understand this? Well, we have done enough questions. We've already reached the end of this. So I leave it here with one last question, because I want you to remember and understand that whatever we have done is done for a purpose. And this is the purpose that I have told you, that you should remember all the ways in which adiabatic process can be written. So can you give me the answer for this one, and then we can call it a day. The correct equation of state for an adiabatic process is dung 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 dung. Which one? And all will look similar, and that is why you'll have to remember them. And the answer is all of you are getting -5. The answer is C, beta, not B, beta. The answer is C, beta. Do we understand this? See, I have forgotten the name of you guys, but I still remember that formula. So that means my short-term memory loss will not affect my profession. It will not be like yours when you leave a scissor in the belly of the patient and then you shout, I will take it out, I will take it out. There was a movie based on this, I think, where an alarm clock was left inside the stomach of the hero, and every 1 hour the alarm clock used to buzz. It was a comedy movie, of course. I don't remember the name of the movie, but that is not important. What is important is what we are going to do in the next class. The next class we'll be doing second law of thermodynamics, and we will be doing thermometry. So I'll see you in the next class. Whatever questions are remaining from this particular topic, please do it on your own. You have an exam on Sunday. I hope you attempt physics and you score there. If there's any problem, I'm always there. I leave on this note. I hope you love this class, and I'll see you tomorrow at the same time. Take care, and may God bless you all. Sayonara. Sayonara means bye-bye.